Hello, my name is Bruce Doctor, and I want to give you a tour of the Hydraulic Engineering Laboratory. I do want to point out that before any of our students are exposed to the laboratory, any of the exercises, they do go through a training seminar, in which case they're explained what their duties are and responsibilities and the safeguards. We also give them a listing of items of particular importance, they have to be aware of, have a document that they have to sign. If they have any questions, they can consult us. We'll do that before they go into the laboratories. I do want to point out that in this particular laboratory, the hydraulic engineering, there are no real specific safety guidelines per se, because really the only materials we work with is water in most of the experiments and a wind tunnel. So there's really nothing that we're exposing the students to that might be considered harmful. However, we do want them to be aware of the criteria that we have set forth in all of our laboratory and every time they're in the laboratories. So if you'd like to follow me, I'd like to show you a tour of the lab. Okay, my equipment that I use for teaching a laboratory class, the first one here is our water table. And what we'll use this water table for is to do a closed conduit evaluation of water through a pipe. And what we're doing is we're looking at 6 differential head measurements. Within the system, we're looking for a Reynolds number and also determining a friction factor. And then we do it for 6 different flows. 3 of them are laminar flows, and 3 of them are turbulent flows. And when they go through their calculations and they figure out the Reynolds number and the friction factor, we have them compare the data that they generated to that on a Moody diagram and talk about the comparison from there. The next exercise that we work on is an open channel flume. With the open channel, we also use the water table as a source of water for our system. What we're determining on the open channel, we're looking at relationships between the water properties on the upstream water flow and the downstream as the water flows underneath a sluice gate. Some of the information that we're looking for is for subcritical and supercritical flow, and we have them construct graphs with that data to determine the critical depth of the sluice gate and when it occurs at what point, and also the corresponding Froude numbers. I do want to point out too that we also have a series of different methods for attachments for determining water flow, different types of flumes. We've got rectangular flumes. We'll also use water flowing underneath a cylinder or a drum. And then we also have a system for a Venturi flume as well, where they can get a visual of the water flow through a Venturi flume. And then we'll use all of those methods to determine the water flow and corresponding. The third piece of equipment I'd like to talk about is our pump characteristics lab. We will operate this anywhere from 1,200 to 1,600 RPMs on our motor. We're looking at anywhere from 1 to 25 gallons per minute of water flow. We do 5 different settings on those. We're looking at power relationships of the motor, and we're collecting information such as the pressure inlet, which occurs at this point, the pressure outlet, which after goes through the motor system over here, and then we're also collecting the torque that's existing on the motor itself, your flow rate, and then your speed in RPM, which is all controlled and monitored through the system here. What we're doing is after those 5 water conditions that we're testing, we're going to determine graphs from them and basically come up with what is considered the most efficient rate. We'll give them a criteria to search for, and they determine from their graphs what is the most efficient pump rate. Another piece of equipment that we use is our turbine for turbine efficiency. We're looking at curve characteristics on the data that's collected for a Pelton wheel. The Pelton wheel is enclosed in here. We're taking readings using a drag force on our wheel that's turning, and then also rotational speed. We're collecting rotational speed by using a regular strobe light for measuring the RPMs, And then we're taking the information, and from that, we will have the students determine what the maximum turbine efficiency is at each of those conditions that we're collecting the data for. Our final laboratory experiment for the hydraulics engineering laboratory is our wind tunnel. What we're doing on there, we're looking at the effects of flow around a circular cylinder. I have pressure valves on each the cylinder on one half. We're hooking these tubes up to a venturimeter here, and we're measuring on the pressure differences as it pertains around the cylinder. From the information, we're going to determine the drag force, number one, accumulation drag force, and also your drag coefficient as well. And then when we've got that information, we'll compare the data on a drag coefficient versus Reynolds number diagram and see where their data points ended up and compared to existing data points for different shapes that are already on a graph of that nature. And that will conclude my tour of the hydraulic engineering laboratory. Thank you again for all your hard work, and if you have any questions at all, please feel free to contact me. Thank you.